Hi everyone, welcome back to our channel, where we explore the wonders of science. Today, we're going to dive into the science behind some of the fascinating natural phenomena on our planet: lightning, earthquakes, and hurricanes. Let's get started. The science of lightning. Lightning is a sudden, powerful discharge of electricity in the atmosphere. It's one of the most intense and fascinating natural events and is still shrouded in mystery. But despite its mystery, scientists have uncovered a lot about the science of lightning. So, what is lightning exactly? Lightning is a type of electrical discharge that occurs in the atmosphere. It's caused by the buildup of electrical charges in the atmosphere, usually between a thunderstorm cloud and the ground. When these charges become strong enough, they can create a spark, which ionizes the air and makes a path for the electrical discharge to flow. The result is a lightning strike, seen as a bright flash of light and heard as a loud crack of thunder. Lightning is mighty and can reach temperatures of up to 50,000 degrees Fahrenheit, 5 times hotter than the sun's surface. But what causes this buildup of electrical charges in the atmosphere? Well, it all starts with thunderstorms. Thunderstorms are formed when warm, moist air rises and cools, forming clouds. As the clouds continue to rise, the water droplets in the clouds collide and form larger droplets, which eventually become heavy enough to fall back to the ground as precipitation. But as the water droplets collide, they also separate electrical charges, with the positive charges rising to the top of the cloud and the negative charges sinking to the bottom. This creates an electrical potential, or voltage, within the cloud, which can be several million volts. When the electrical potential within the cloud becomes strong enough, a spark can occur, ionizing the air and creating a path for the electrical discharge to flow. This spark is what we see and hear as a lightning strike. But not all lightning strikes are created equal. There are several different types of lightning strikes, each with unique characteristics. One of the most common types of lightning strikes is called a cloud-to-ground lightning strike, which is precisely what it sounds like: a discharge of electricity from a thunderstorm cloud to the ground. Another type of lightning strike is called intra-cloud lightning, a discharge of electricity within a thunderstorm cloud. This type of lightning is not typically visible from the ground, but it's still compelling and can create strong electric fields within the cloud. Yet another type of lightning strike is called ground-to-cloud lightning, a discharge of electricity from the ground into a thunderstorm cloud. This type of lightning is relatively rare. The science of earthquakes. Earthquakes are among the most influential and destructive natural disasters, causing widespread damage and loss of life. But what exactly are earthquakes, and how do they occur? First, let us look closely at the science behind earthquakes and what causes them. 1. What are earthquakes? An earthquake is a sudden and intense shaking of the ground caused by the movement of the Earth's crust. Earthquakes can occur anywhere in the world but are most common along tectonic plate boundaries, where two plates meet and grind against each other. The energy that causes earthquakes is stored in the Earth's crust and is released when the plates suddenly shift, causing the ground to shake. Earthquakes can range in magnitude from tiny, barely noticeable trembles to massive, catastrophic events that can cause widespread damage and loss of life. 2. Tectonic plates and plate boundaries. The Earth's crust consists of several large plates, known as tectonic plates, constantly moving and shifting. These plates are constantly moving, driven by forces within the Earth's mantle. When two plates collide, they can cause friction, which can build up over time and eventually result in an earthquake. There are 3 types of plate boundaries: divergent, convergent, and transform. At divergent boundaries, two plates move away from each other, creating new crust. At convergent boundaries, two plates move toward each other, and one plate is pushed beneath the other, creating deep oceanic trenches. Finally, at transform boundaries, two plates slide past each other horizontally, causing earthquakes and creating faults. 3. Measuring earthquakes, magnitude and intensity. Earthquakes are measured by their magnitude and intensity. Magnitude is a measure of the size of the earthquake and is determined by the amount of energy released. The Richter scale is the most commonly used scale for measuring earthquake magnitude, with a magnitude of 7 or higher considered a major earthquake. Intensity, however, measures the strength of the shaking and its effects on people and buildings. The modified Mercalli intensity scale measures earthquake intensity, ranging from I, not felt, to 12, destruction. 4. Predicting earthquakes. While it's impossible to predict earthquakes accurately, scientists can use various techniques to estimate the likelihood of earthquakes occurring in a specific area. This includes analyzing seismic activity, studying the behavior of faults, and monitoring changes in the Earth's crust. One method of predicting earthquakes is called seismology, which involves monitoring seismic activity in a particular area. Seismologists can use this data to identify patterns and predict future earthquakes. Another method is called geodesy, which involves monitoring changes in the Earth's crust. Scientists can use this data to identify areas likely to experience earthquakes and predict when they may occur. 5. Protecting against earthquakes. While it's impossible to prevent earthquakes from occurring, steps can be taken to reduce the risk of damage and loss of life. This includes building earthquake-resistant buildings, developing early warning systems, and improving infrastructure to withstand earthquakes. Building codes and standards can help ensure that new buildings are designed and built to withstand earthquakes. This includes using seismic-resistant materials, such as reinforced concrete and steel, and providing that buildings are anchored to the ground to prevent them from collapsing. Early warning systems can also help reduce the risk of damage and loss of life. These systems use sensors to detect the initial shockwaves from an earthquake and provide an early warning to those affected, allowing them to take appropriate action, such as evacuating buildings or finding safe shelter. Finally, improving infrastructure to withstand earthquakes can help reduce the risk of damage and loss of life. This includes upgrading roads, bridges, and other critical infrastructure to withstand earthquakes. Therefore, earthquakes are powerful and destructive natural disasters that can cause widespread damage and loss of life. But by understanding the science behind earthquakes and taking steps to protect against them, we can reduce the risk of damage and loss of life and ensure that we are prepared for the next big earthquake. Science of hurricanes. Hurricanes are one of the most potent natural phenomena on Earth. They are massive storms that form over the ocean and can cause widespread damage and destruction when they land. But how do these storms form, and what makes them so powerful? That's what we're going to explore today. To understand hurricanes, we need to start with the basics. A hurricane is a tropical cyclone, a rotating low-pressure weather system that forms over tropical oceans. The critical ingredient for a hurricane to form is warm, moist air. When the air over the ocean is heated, it rises and comprises a low-pressure area. As the air rises, it cools and condenses, forming clouds. As the warm, moist air rises, it creates a rotating system of winds. This is because the Earth's rotation causes the winds to turn, creating a low-pressure area in the center. This low-pressure area is known as the eye of the storm. The eye of the hurricane is surrounded by a ring of intense thunderstorms, known as the eye wall. This is where the strongest winds and heaviest rainfall occur. A hurricane needs to continue feeding on warm, moist air from the ocean to maintain its strength. This is why hurricanes typically form over warm tropical oceans, such as the Atlantic or Pacific. So, what makes hurricanes so powerful? The answer lies in the heat energy released as the moist air rises and cools. This heat energy fuels the storm, creating strong winds and heavy rainfall. The strength of a hurricane is measured by its maximum sustained winds and central pressure. The lower the central pressure, the stronger the hurricane. Hurricanes are classified into 5 categories, ranging from Category 1 to Category 5, based on their maximum sustained winds and central pressure. The higher the category, the stronger the hurricane and the greater the potential for damage and destruction. When a hurricane makes landfall, it can cause widespread damage and destruction. The strong winds and heavy rainfall can cause widespread flooding, while the storm surge can cause coastal erosion and inundation. It's important to remember that hurricanes can be unpredictable, and their impact can vary greatly depending on the location and the conditions. This is why it's essential to be prepared and have a plan in case of a hurricane. It's also important to remember the impact of hurricanes on the environment. Storms can cause significant harm to ecosystems, wildlife, and habitats. They can also contribute to climate change by releasing large amounts of heat and carbon dioxide into the atmosphere. We must continue studying hurricanes and their environmental impact to better understand and prepare for their effects. This includes using technology and data to track and predict storms and implementing measures to reduce their impact on the environment and communities. So there you have it, the science behind some of the fascinating natural phenomena on our planet. Lightning, earthquakes, and hurricanes are all powerful and dangerous, but they're also essential for understanding the Earth and its processes. Thank you for watching this video about the science of earthquakes. If you have any questions or comments, please leave them in the comments section below. And don't forget to like, comment, and subscribe for more science content.